welcome back to HEOR Insights. In this video, we are going to simplify three very important measures used in HEOR and clinical research: odds ratio, relative risk, and hazard ratio. These terms often appear in research papers and clinical trial results, but many people struggle to understand what they actually mean. So let us break them down step by step with simple examples and clear interpretation. In healthcare research, we often want to know how much an exposure or treatment changes the risk of an outcome. For example, how much does a new drug reduce hospitalization, or how much does a smoking increase the risk of lung cancer? That is where OR, RR, and HR comes in. They help us quantify and compare risk between groups, and they are central to clinical trials, epidemiological studies, and HEOR evaluations. Simply put, these ratios turn data into meaningful decision-making evidence. Let us start with the odds ratio. Odds ratio compares the odds of an event happening in one group to the odds in another group. It is mostly used in case control studies or logistic regression, where we don't know the total population risk, but can compare how much more likely one group is to have an outcome. The formula is A by B divided by C by D, or simply the risk in one group to the risk in another group. If OR values is equal to 1, there is no difference between the groups. If OR is greater than 1, the event is more likely in the exposed or treatment group. If the OR is less than 1, the event is less likely in that group. Let us take an example. Suppose we are studying smoking and lung cancer. Among 100 smokers, 80 developed lung cancer and 20 didn't. Among 100 non-smokers, 20 developed lung cancer and 80 did not. The odds for smokers is 80 divided by 2, which is equal to 4, and the odds for non-smoker is 20 divided by 80, which is equal to 0.25. So the odds ratio will be 4 divided by 0.25, which is equal to 16. That means smokers have 16 times higher odds of developing lung cancer than non-smokers. But remember, when the disease is common or tends to exaggerate the risk, so it's more useful for rare outcomes. Now let's look at relative risk, also called risk ratio. This measure compares the actual probability of an event occurring between two groups, not the odds, but the direct chance. The formula is risk in treatment group divided by risk in control group. If RR is equal to 1, there is no difference. If RR is greater than 1, higher risk in treatment group. If RR is less than 1, that means lower risk in treatment group. Relative risk is commonly used in cohort studies and randomized clinical trials because it is easy to interpret and closer to real-world meaning. Let us take an example with a vaccine study. Suppose 10% of unvaccinated people get the flu, but only 2% of vaccinated people do. Relative risk is equal to 0.02 divided by 0.10, which is equal to 0.2. That means the vaccinated group has only 20% of the risk, or in other words, there is an 80% reduction in risk compared to those unvaccinated. This is why relative risk is often used in public health. It communicates the benefit or harm of an intervention very clearly. Now comes the hazard ratio, which is slightly different. Hazard ratio measures the difference in time to an event, like time to death, time to relapse, or time to hospitalization between two groups. It is used in survival analysis, often along with Kaplan-Meier curves or Cox regression models. If HR is equal to 1, there is no difference in event timing. If HR is greater than 1, event happens faster in treatment group. If HR is less than 1, event happens slower, which is often good. The key difference: HR looks at how quickly events occur, not just how often. For example, in a cancer trial, a new drug shows a hazard ratio of 0.75 for death compared to standard therapy. That means at any given time, patients taking the new drug have a 25% lower risk of death. So while RR looks at the overall probability, HR looks at the speed or rate of events over time. This makes HR extremely useful for long-term studies and time-to-event data. Let us quickly summarize all the three measures. Odds ratio compares odds best for case control studies. Relative risk compares probabilities best for cohort studies or clinical trials. Hazard ratio compares event rates over time best for survival analysis. So OR is for association, RR is for risk, and HR is for time-dependent risk. Each tells a different part of the same story, the relationship between exposure and outcome. To wrap up, always choose the right measure based on your study design and data type. Report results with confidence intervals to show reliability, not just p-values. Most importantly, don't just quote the numbers, interpret what they mean in a clinical or economic context. These ratios help us move from data to decision, which is the core of HEOR. If you find this video useful, don't forget to subscribe to HEOR Insights and share them with your peers who are learning HEOR and clinical analytics. Thanks for watching and see you in the next video.